everyone. Today we're going to learn about congruent figures and we're going to do our best to catch up from that fire drill. Okay, so our warm-up here asks us which figures have the same shape and size. Well, the only ones that are the same shape and also happen to be the same size are your triangles. And that's the perfect introduction to today's topic. Okay. The next page says Mrs. McWilliams has a curtain with the pattern of cubes shown. What do you notice about the cubes in each block of color? Okay, so yes, there's lots of colors here, but hopefully you're noticing that they're all the same shape and size, just different colors. And that's really our definition of congruence. And we have talked about congruent angles before. Now we're going to broaden that and talk about congruent figures. Okay, so figures are congruent if they have the same shape and size. Pretty straightforward. When you're all set, flip the page. These examples are pretty straightforward, pretty simple. The first one says, identify the figures that seem congruent. Explain why they seem so. Again, looking for figures that are the same shape and size. So for example, C and E, although they are the same shape, are different sizes. So we cannot say that those are congruent. Don't get fooled by A and F. Those are different shapes, leaving us with B and D being congruent because they're the same shape, same size. Give these practice problems a try, pause, and come back. Okay, hopefully these were pretty easy. We should be matching C with D and then A with F. Same shape, same size. They don't have to be facing the same direction. And then for number 2 here, C and D are the same shape, same size, again, although they're not facing the same direction. Correct your papers and then flip the page. Okay, so now let's really kind of dive in and relate what we know about these figures to some shapes. Okay, corresponding angles. Okay, so given two congruent figures, we can find corresponding angles. Okay, so this is a pair of matching angles in two congruent polygons I'll just leave it at that. A pair of matching angles in two congruent polygons. And then corresponding sides, I'm sure you could guess, is a pair of sides a pair of matching sides, sorry. Into congruent polygons. Okay. So if we look at the diagram here to the right, okay, we have congruent angles. Okay, the measure of angle A, that's up here, is equal to the measure of angle D. Okay, those are corresponding angles They are the same measure. They are congruent. Okay, then you have angle B is congruent to E. Okay, and that's tricky for some people because they don't necessarily realize that it's been flipped. Okay, the angles have to be in the same position no matter which direction it's facing. So B is corresponding with E and they are congruent. And then lastly, C is corresponding with F and they are congruent. Okay, we could do the same thing with the sides. Okay, so you have AB is equal to DE. Okay, so AB's here matching with DE. And then BC, that's this here, matching with EF, and AC matching with DF. And you'll notice how the matching angles have the same number of bars, the matching sides have the same number of little dashes. That's how you show congruence and that they're corresponding. Okay, and then we have our statement of congruence down here. Okay, and because we have congruent angles and congruent sides, we can say the triangle ABC is congruent to DEF. Okay, so let's take a look at the examples down below. Okay, we can say that angle P corresponds with angle Z. Okay, that's this here and this here. We can say that angle R corresponds with angle X, and that angle Q corresponds with angle Y. And because all three angles have a corresponding angle in the other triangle, we can write our statement that says triangle PRQ is congruent to triangle ZXY. Okay, and you do have to match them up. Okay, so when I write this triangle, P needs to match with Z, R needs to match with X, and then Q needs to match with Y. Okay, looking at the next one. Okay, these we're looking at sides. Okay, so we can say that XY corresponds to or is congruent to ST. And that YZ corresponds to, let's see here, YZ is here, SU, and then XZ corresponding with TU. Okay, so we can say that triangle XYZ is congruent to triangle T is in the same spot as X, S is in the same spot as Y, and U is in the same spot as Z. So we would say X matches with T, Y is the S, and Z is the U. There we go. Jot down any questions you have and then flip the page. Okay, here's one for you to try. It says the quadrilaterals below are congruent. Write the statement of congruence. So first, go ahead and find your corresponding angles and then finish the statement right here. Come back to me when you're ready. Okay, now that you've given that a try, let's go over this. Angle P is congruent to angle U. Angle Q is congruent to V, R congruent to W, and S congruent to T. So we can say that this quadrilateral PQRS is congruent to UVWT. Jot down any questions you might have. Okay, now this part, we want to find unknown measures. Okay, so solving for variables in congruent figures. This one says Chloe cut a piece of rectangular paper along one of its diagonals. Okay, and hopefully we recognize that rectangular paper cut along diagonal makes two triangles. We have A, B, C, and D, E, F. Find the values of X and Y. Okay. Well, because A is corresponding to D, okay, if you notice where all the sides are lining up, you have AC lining up with DF, okay, and then the other two. So we know that the measure of angle A is congruent to the measure of angle D. And if A equals 55 degrees, then D must equal 55 degrees, which means that X equals 55 degrees. Okay. We also know that the measure of angle B is congruent to the measure of angle E because they're both right angles. And then lastly, okay, we have that the measure of angle C is congruent to the measure of angle F. Okay. In order to find C, okay, we know that the three interior angles of a triangle add up to 180, so we can do angle C plus 90 plus 55 equals 180. Okay, so we get the measure of angle C plus 145 equals 180. Subtract, the measure of angle C equals 35 degrees. And if C is 35, then F must be 35, which means we now have the value of Y is 35 degrees. Okay. So it's really like a puzzle, okay, solving for those variables. Go ahead and flip the page, please. You have one to try on your own. Pause the video and come back to me when you're ready. Okay, now that you've had a chance to try this, let's go over it. Side GH is equal to LM. Okay, so GH is 12 is equal to LM. This is really nice because now we know that X equals 12 because they have to have the same measure. Okay, we were also given that HI is equal to MN. Okay, those are corresponding. Next, IJ is equal to NK. IJ, NK. Okay, this one's a little funky because those two pieces are equal. This piece and this piece. So we want to literally set them equal. Okay, so if we do 2y minus 5 equals y plus 2, it allows us to solve for y. Okay, so the first thing we're going to do is subtract the smaller variable. 2y minus y is just plain old y, minus the 5 equals the 2 that we left on the other side. Add 5 to both sides, and we get that y equals 7. Okay, so now we have what the value of x is, the value of y. We're doing good. Okay, and then lastly, we know that JG is equal to KL. Okay. For this one, we now know that x minus 6 is equal to z. And because we know x is 12, we can plug that in. 12 minus 6 is 6, so z must equal 6. Okay? And if you wanted to know the length of each side, we can just plug the values in. Okay, GH was given 12 inches. HI, we can do 2 times 6 minus 2 equals 10. IJ equals 2 times 7 minus 5 equals 9. JG equals 12 minus 6, which is 6. And because GH corresponds with LM, we know that LM equals 12. HI corresponds with MN, so this must be 10. IJ corresponds with NK, so that must be 9. And then JG corresponds with KL, so they must also have the same measure. It's a slow process, but I think it's not too bad. Correct your paper and jot down any questions you might have. Okay, lastly, okay, are what we call proofs. And you'll get into this way more in 10th grade, but this is just a little taste. It says the sets of minimum conditions for two congruent triangles are as follows. Two triangles are congruent if they satisfy any of these different sets of conditions. And if they don't, then we would say they're not congruent. Okay, so the first one is what we call the side angle side test. Two pairs of corresponding sides are congruent and the corresponding angles included between these sides are congruent. Okay, so you have side, angle, side. Okay, the angle should be sandwiched in between two different sides. If we can prove that, then you can prove that the two triangles are congruent. The next one is angle, angle, side, or angle, side, angle. Okay? So what we have here says two pairs of corresponding angles are congruent and any side of one triangle is congruent to the corresponding side of the other triangle. Okay, so that's angle, angle, side, or angle, side, angle. Next one is side, side, side. And this you saw before, you just didn't know that it had that name earlier in the packet, where all three pairs of corresponding sides are congruent. Okay. And then lastly, we have this funky one called the hypotenuse leg test. Okay, the hypotenuse of a right triangle is congruent to the hypotenuse of the other right triangle. Okay, so we have our hypotenuse is congruent. Another side is congruent. Okay, so one of the legs, okay, and it has to be a right triangle. Okay, so a hypotenuse leg test only works for right angles. Okay. You cannot use side, side, angle except when it's hypotenuse leg. Okay, so that's important every time someone tries to use that and it doesn't work. Okay, I like to remember it because backwards it spells a bad word. We don't like bad words, we can't use that. Okay? This is going to be funky. Okay, give it a try. and then we'll go over it when I see you on Monday. Okay, so flip the page and let's look at a few of these. Okay, it says identify the congruent triangles, write the statement of congruence, and state the test used. Okay, so we have ABCD as a parallelogram and we have the diagonal. AB and CD are congruent. Okay, so I'm going to start by saying that AB equals CD. Okay, and similarly, I'm also going to say that AD is equal to BC. Okay, my reasoning for both of those is that opposite sides of a parallelogram are congruent. Okay, that's just a fact. And I hope that you know that by now. You know, if I gave you a rectangle, you would be able to tell me that the opposite sides of a rectangle have the same measure. Okay, and that's just what I did here. The other thing we can say, and this is a little funky, we can say that AC equals AC because it technically belongs to two different triangles. AC belongs to this triangle. It also belongs to this triangle. So we can use it in this way, and we can say it equals itself because it is a common side of both triangles. Okay, so what we just proved is that we have three pairs of congruent sides. So we can say that triangle ABC is congruent to triangle CDA by side, side, side test. Again, kind of funky. Jot down questions that you might have. Okay, part B. Here we go. AD is the angle bisector. Okay, this is something you haven't seen much of, but an angle bisector cuts an angle in half. Okay, so it's the bisector of angle A and angle D. Okay, so there's a couple things that we can notice. Okay, if this line is cutting these two angles in half, then this angle is the same as this angle, and this one is the same as this one. And hopefully this side is the same as itself. So what we're looking to prove here is angle, side, angle. Okay, so we have the measure of angle BAD, okay, that's this one here, equals the measure of angle CAD. And the measure of angle BDA equals the measure of angle CDA. And this is because an angle bisector divides an angle equally. Okay, and then just like before, we can say that AD equals AD because it's a common side. Therefore, we can say triangle ABD is congruent to triangle ACB by angle, side, angle test. Okay. Last one, and then I'll let you quit. Thanks for sticking with me. We have AD is perpendicular to BC. Okay, and then they've marked that these two sides are congruent. Okay, if this is perpendicular, then this is a right angle and this is a right angle. So what we could try to figure out here, or try to prove, is the hypotenuse leg test. Okay. So we have here that triangle ADB and triangle ADC are right triangles. We have that AB equals AC. Okay, that was pretty much given. Okay, and then AD equals AD. Okay, so this side is your leg, and we had the hypotenuse. Okay, and we have right triangles, so we can say that triangle ADB is congruent to triangle ADC by the hypotenuse leg test. Okay. On the next page, we were going to do some practice. I'm not going to torture you by making you do that, but you should know that this one here, you can do side, angle, side. Okay, and then this one down here is not, actually I shouldn't say that. We can't prove that they are congruent. There's not enough information to prove one of those tests, so it doesn't work. And that's it. Okay, I know we just covered a lot. Thank you for sticking with me. Use this video and your notes to help you with the homework. Have a good night.